As we discussed several times, our LGD model will have two stages. We have already created a logistic regression to determine whether recovery rate is 0 or above 0. In this lecture, we will build a linear regression to determine the exact recovery rate of observations that are predicted to be above 0. Okay, the model will be a multiple linear regression model that will estimate the recovery rate for all borrowers with recovery rate predicted above 0. If you recall, we coded them with 1s in the recovery rate 0, 1 column, so we can use it to filter them for the rest. Let's create a new data frame that will contain them. Then we should split the data into train and test once more. Let LGD input stage 2 train, LGD input stage 2 test, LGD target stage 2 train, LGD target stage 2 test equal train test split. We will use the data from LGD stage 2 data except for columns containing dependent variables, so good bad, recovery rate 0, 1, and credit conversion factor. This time, the recovery rate itself is a target variable. Again, let the test size be 20% and let's apply the random split that corresponds to random state 42. Great! To run the linear regression model, we need to import the linear model method from sklearn. Later, to assess how well it performs, we will need the methods mean squared error and R2score from sklearn metrics. Similar to the logistic regression, the linear regression class in sklearn does not show p-values for the estimated regression coefficients. So, to see the p-values, we must alter it, just like we already did with the logistic regression method. Here's the code for the altered linear regression class. Now we can proceed to estimating the model. Let's pre-select only the input variables we need. They are the variables from LGD input stage 2 train whose names are contained in the features all list. Then we drop the reference categories contained in the features reference categories list. Okay, let's proceed to the regression itself. Let regression LGD stage 2 be an instance of the linear regression class. To fit the regression, we use LGD input stage 2 train as inputs and LGD target stage 2 train as targets. Now that our regression has been estimated, we can create a summary table just as we did for our logistic regressions model. In fact, we can use the same code. Of course, we have to change the object from where the coefficients, the intercept, and the p-values are taken from. And here are the regression coefficients of the second stage of our model, the linear regression model. That's awesome! We have estimated the second stage of the LGD model and displayed its coefficients. Here, a larger number of regression coefficients are statistically significant, and unlike the logistic regression, the interpretation of the coefficients is much easier. The coefficient shows the change in the dependent variable that is going to occur with a unit change in the respective independent variable. For example, if the purpose of the loan is educational, it is expected that the recovery rate would be 7.63% higher. Also, each dollar increase in annual income is expected to result in 0.000064% higher recovery rate. Moreover, every percentage increase in interest rate is expected to result in 2.545% lower recovery. Okay, in the next lecture, we will evaluate the second stage of our LGD model. Thanks for watching.